Today we'll be doing a lesson that was very similar to what we did last week, the sum and difference formulas of sine and cosine, but today we're going to be using tangent. Now here are the two formulas we use. We have the sum and the difference. Notice that the sum has a plus in the numerator and a minus in the denominator. If you look at the minus formula, alpha minus beta, we have an alpha minus in the numerator and a plus in the denominator. These formulas are both on your blue sheet, so you will have them. Just make sure that you notice that with the plus, you have the plus in the numerator, minus in the denominator, and with the minus, you have minus in the numerator, plus in the denominator. For this example, we will use the difference formula. The difference formula for tangent is, if we have the tangent of alpha minus beta, it will be equal to the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta. For this, we will have to know what alpha is equal to and what beta is equal to. Well, in this case, alpha is equal to pi, and beta is equal to theta. So we will substitute those values into our equation. So anywhere we see an alpha, we'll put a pi. Anywhere we see a beta, we put theta. So we will have the tangent of pi minus the tangent of theta over 1 plus the tangent of pi times the tangent of theta. Now that we have our values substituted into alpha and beta, we can start simplifying. Looking at the tangent of pi, we know that the tangent is pi from looking at our unit circle is 0. And we don't know what the tangent of theta is, so we just leave it as minus tangent of theta over 1 plus tangent of pi, again, is 0, so we have 0 times the tangent of theta. Now we can do a little bit more simplifying. We know that 0 times tangent is just 0, and we don't have to worry about the 0 in the numerator, so we will have negative tangent theta over 1. Well, and that is just equal to the negative tangent of theta. So that is our final answer. Now, this question that we just did is similar to problems 21 and 24 from your homework. So if you have problems with those, check out this example. Now, go ahead, do this one yourself. Notice that instead of the difference formula, we will use the addition formula, the sum formula, so make sure you note that whenever you pick your formula. Go ahead and pause this video and work this out yourself, and then unpause it to check your answer. So here is the solution to this problem. When you simplify the tangent of pi over 3 plus pi over 4, you will get root 3 plus 1 over 1 minus root 3. And again, this is like problems 21 and 24 of your homework. For this problem, we have to verify that the tangent of pi minus theta is equal to the negative tangent of theta. So notice we have pi minus theta, so we will be using the difference formula. So we will be using the tangent of alpha minus beta is equal to the tangent of alpha minus the tangent of beta over 1 plus the tangent of alpha times the tangent of beta. So now we know what alpha and beta are. So alpha is equal to pi. Beta is equal to theta. So now we just need to substitute these into our formula. So we will have the tangent of pi minus the tangent of theta over 1 plus the tangent of pi times the tangent of theta. Now let's do some simplifying. The tangent of pi is just 0. So we have 0 minus the tangent of theta over 1 plus tangent of pi is 0. So we have 0 times the tangent of theta. Well, we know that 0 minus the tangent of theta is just negative tangent theta. And 0 times tangent on the bottom of here is just 0, so we're left with 1. So our final answer will be negative tangent of theta, which is what we wanted to get to, so we are done. And this problem is like 33 through 39 in your homework. So for this problem, we will use stuff we did last week. So we have to use the sine sum formula. Remember that the sine sum formula is the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. From our original problem, we know that alpha is equal to theta and beta is equal to 3 pi over 2. And we're going to try to simplify our formula to get to the negative cosine times the cosine of beta plus the cosine of alpha times the sine of beta. Now we need to know what alpha and beta are. Alpha is equal to theta. Beta is equal to 3 pi over 2. And remember that our goal is to get to a negative cosine of theta. So let's go ahead and substitute what we can. So we'll have the sine of theta times the cosine of 3 pi over 2 plus the cosine of theta times the sine of 3 pi over 2. So we know that from our unit circle that the cosine of 3 pi over 2 is 0, so we'll have the sine of theta times 0 plus cosine of theta times the sine of 3 pi over 2, but from our unit circle we know that the sine of 3 pi over 2 is negative 1, so it'll be cosine of theta times negative 1. Well, sine of theta times 0 is just 0, plus the cosine times negative 1, which is just negative cosine of theta. So that leaves us with a negative cosine of theta, which was what our goal was. For this next example, in your packets, it looks like for this part, it says cosine of alpha minus beta times 2 cosine alpha cosine beta, but there is an equal sign there. So we are trying to get the left side, cosine alpha plus beta plus cosine alpha minus beta, equal to 2 cosine alpha, 2 cosine beta. So go ahead, work through this. Pause the video, work through it, and see if you can verify this identity. When you're done, unpause the video to get the solution. So here is the solution to this problem. We had to get cosine of alpha plus beta plus the cosine of alpha minus beta equal to 2 cosine alpha cosine beta. And this is what you should have had. For this problem, we will have to write the expression as the tangent of an angle, then find the exact value of the expression, the tangent of 10 degrees plus the tangent of 35 degrees, over 1 minus the tangent of 10 degrees, tangent of 35 degrees. So for this problem, we'll have to notice that there is a plus in the numerator and the minus in the denominator. That means we will have to use the tangent sum formula, so the tangent of alpha plus beta, and that is equal to the tangent of alpha times plus the tangent of beta over 1 minus tangent of alpha times the tangent of beta. So if you notice, the problem that we're given looks just like this one below, except where there's alpha and betas. In our original problem, we have 10 degrees and 35 degrees. So from that, we can tell that alpha is equal to 10 degrees and beta is equal to 35 degrees. So we know that we can write this as the tangent of 10 degrees plus 35 degrees. So that answers the first part of the problem, is write the expression as the tangent of an angle. Well, we wrote it as tangent of 10 degrees plus 35 degrees, which we know that is equal to tangent of 45 degrees. And now we have to find the exact value of the expression. Well, the tangent of 45 degrees from our unit circle we know is equal to 1. And on your homework, this is like problems 27 and 30. So if you have trouble on those, check out this example. It should help you out. Now, I know this problem isn't in your note packet, but you do have a homework problem like that. So we'll go ahead and look at this example a little bit so we know how to do it on our homework. For this problem, we need to find the exact value under the given conditions. So we need to find the cosine of alpha plus beta, the sine of alpha plus beta, and the tangent of alpha plus beta. So we will have to know what the cosine of alpha is equal to, and the cosine of beta, the sine of alpha, the sine of beta, and the tangent of alpha and the tangent of beta. Once we know all of these, we'll be able to use our sum and difference formulas to find A, B, and C. So to find cosine alpha and beta, sine alpha and beta, tangent alpha and beta, we're going to have to use something we learned from the last chapter, and we're going to have to observe or look at the sine of alpha equal to 3/5, so we know that one already, and the sine of beta being 5/13. And remember that the sine is equal to x over r. So we know the x value for the alpha and the r value for alpha, and we know the x value for beta and the r value for beta. To find our cosine and tangent values, we're going to have to look at the sine of alpha equal to 3/5, and the sine of beta, which is equal to 5/13. Now remember from the last chapter that these give us the y and the r values for alpha and beta. And we'll have to use those to find our cosine and tangent. So really, all we need to find is the x value for each of those. And we're going to do that using the Pythagorean theorem. So let's find the alpha values first. So we will use the formula r squared is equal to x squared plus y squared. Well, we know what r is, 5, so we have 5 squared equal to, we don't know x, so it'll be x squared, plus 3 squared. Well, 5 squared is 25, and 3 squared is 9, so we know that x squared is equal to 16, and therefore x is equal to 4. So now we know our cosine of alpha values. Cosine being x over r, so 4 over 5. Now we can find our beta value, and we're going to use our Pythagorean theorem again. R squared equals x squared plus y squared. This time r is equal to 13. We still don't know x, so we'll have x squared. And we know that y is equal to 5, so we will have 5 squared. 13 squared is 169, so we know that 169 is equal to x squared plus 5 squared, which is 25. So now we have to subtract 25 from both sides, so we know that 144 is equal to x squared, making x equal to 12, and then now we know our cosine of beta, which is going to be 12 over 13. And then we can find our tangent of alpha and tangent of beta. Remember, tangent is y over x, so tangent of alpha is equal to 3 over 4. And tangent of beta is going to be equal to 5 over 12. From here, you will then use all these values to find your cosine of alpha plus beta, your sine of alpha plus beta, and your tangent of alpha plus beta using your sum formulas from your blue sheet. So that should get you going pretty good on how to do this problem. That problem is number 58 on your homework. So that should get you going pretty good on our homework, which is page 604, 21 through 39, multiples of 3, and numbers 58. Use the remainder of class to work on this homework, and you will turn in first thing tomorrow when you get into class.